Tonight, go outside, look up, find the constellation Andromeda. You'll see a faint smudge of light, easy to miss, looks like a small cloud. That's not a cloud. That's 1 trillion stars, 2.5 million light years away. And it's moving toward us, right now, every second, closing the distance. In about 5 billion years, it arrives. And when it does, everything we call home will cease to exist.
The light you see when you look at Andromeda tonight left that galaxy 2.5 million years ago. When that light began its journey through space, our ancestors were making their first stone tools in Africa. Homo sapiens didn't exist yet. Civilization was unimaginable. And that light has been traveling ever since, through the void, across the universe, until tonight, when it reached your eyes.
For centuries, astronomers argued about what Andromeda was. A gas cloud inside our galaxy? A distant nebula? Nobody knew. Until 1924, when Edwin Hubble pointed the most powerful telescope on Earth at it and measured its distance. And the answer shook astronomy to its core. It wasn't part of the Milky Way at all. It was an entire separate galaxy. Billions of stars, its own structure, its own fate. But there was already a clue that something unusual was happening. In 1913, astronomer Vesto Slipher analyzed Andromeda's light and found something almost every other galaxy doesn't show: blue shift. The light was compressed, squeezed toward shorter wavelengths, which means only one thing in physics: it's coming toward us, not away, toward. Let's understand what Andromeda actually is. The Milky Way contains somewhere between 200 and 400 billion stars. Andromeda contains roughly 1 trillion, more than twice as many. Its disk stretches over 200,000 light years across, more than twice the width of our galaxy. And here's something most people have never been told. If your eyes were sensitive enough to see all of Andromeda's faint outer light, it would appear 6 times wider than the full moon in your night sky. 6 full moons side by side. That's how large it actually is above us right now. We just can't see most of it. The outer regions are too faint to detect without instruments. But it's there, every single night. Vast, massive, approaching. It's moving toward us at 110 kilometers per second. That sounds fast. It's not fast enough. The gap is so enormous that even at that speed, the first close pass won't happen for roughly 4 to 5 billion years. Gravity is patient. It doesn't rush.
When you hear the words galactic collision, you probably picture catastrophe, explosions, stars slamming into each other, destruction. That's not what happens. Galaxies are mostly empty space. The distance from our sun to the nearest star is 4.2 light years, almost entirely void. When Andromeda and the Milky Way meet, the chance of any 2 stars actually colliding is almost zero. What happens instead is stranger and more beautiful. The gravitational fields of 2 galaxies, each containing hundreds of billions of stars, begin to interact. Stars are pulled off their orbits. Some are flung outward, becoming rogue stars, drifting alone through the void between galaxies, permanently ejected, belonging to nothing. Others are pulled inward. The spiral arms, the elegant structures we see in photographs, are torn apart by tidal forces and reformed into something unrecognizable. And gas clouds collide. When gas clouds from 2 galaxies meet and compress, they trigger star formation. Massive bursts of new stars igniting across the merged structure. Thousands, millions.
At the center of our Milky Way sits a supermassive black hole called Sagittarius A. Its mass, 4 million suns. At the center of Andromeda sits a different black hole. Its mass, roughly 100 million suns, 25 times larger than ours. When the galaxies merge, these two black holes don't immediately collide. At first, they're separated by thousands of light years, but gravity pulls them together. They begin to orbit each other, a binary system, two supermassive black holes spiraling inward over millions of years. As they spiral closer, they orbit faster. They emit gravitational waves, ripples in the fabric of space-time itself, losing energy with every orbit, shrinking the gap, accelerating toward each other. And then they merge. For a brief instant, the power carried away by gravitational waves exceeds the combined light output of all the stars in the observable universe. More power than 100 million galaxies, released as ripples in space-time, detectable across the cosmos. The new black hole rings like a struck bell as it settles into its final shape. And then it goes still.
What emerges from all of this isn't the Milky Way anymore. It isn't Andromeda. It's something entirely new. Scientists have named it Milkomeda, not a spiral galaxy. The collision destroys that. An elliptical galaxy. A vast, roughly spherical cloud of stars, larger than either galaxy was alone. The spiral arms we've known our entire existence as a species, gone. The flat disk where our solar system has orbited for billions of years, disrupted, reformed, or gone. Our home, unrecognizable. Our sun will probably survive, but it will be in a completely different part of the galaxy, different neighbors, different sky. The constellations you know, Orion, the Big Dipper, Cassiopeia, gone, scattered by forces that have been set in motion tonight while you sleep. 4 to 5 billion years. That's longer than Earth has had complex life. It's 6 times longer than multicellular organisms have existed on this planet. Whatever humanity becomes in that time, if we survive, if we evolve, if we spread across the stars, we will be utterly unrecognizable. Not human, not anything we could imagine tonight. But right now, tonight, go outside. Find that faint smudge in the constellation Andromeda. Cover it with your thumbnail. 1 trillion stars, moving toward us. It has been moving toward us since before humans existed. It will keep moving after everything we've ever built is gone. Gravity doesn't stop. It doesn't negotiate. It just pulls. Slowly, patiently, inevitably, until home stops being home.